Hello, my name is Michaela Vanderveen, and I'm a delegate for the MEC Multi-Access Edge Computing Industry Specification Group. Today, I'm very pleased to present this episode of the MEC Tech series focusing on MEC API security. In this episode, we will learn the difference between authentication and authorization, two terms sometimes used interchangeably or incorrectly. The basis of two commonly used protocols for authentication and authorization, and we will end with tips how to avoid pitfalls in implementation of these protocols to protect the ETSI-MEC interfaces shown here to the right. Authentication is about verifying the identity of a communication peer. Based on it, keys for encryption and integrity protection can be derived. This is TLS, Transport Layer Security. A TLS tunnel protects data from being eavesdropped or modified in transit. RESTful MEC APIs are to use HTTPS, that is, HTTP run over a TLS tunnel. Authorization, on the other hand, is about obtaining a permission to access a restricted resource and then obtaining that resource. An example is OAuth 2.0, where a client gets an access token and shows it to the resource server and obtains that resource back. RESTful MEC APIs are to employ OAuth 2.0. Underpinning these security protocols are digital certificates. They are crypto data used to prove your identity to other parties. A valid certificate is issued by a certificate authority to say that the entity or owner is deemed trustworthy. Certificates have a lifetime after which they expire. This means that the owner is no longer trustworthy. TLS connections must then be dropped mid-session if this happens. Certificates can be revoked by that certificate authority if it determines that the owner is no longer trustworthy. TLS connections should only be set up if the other party shows a valid certificate. Widely used standard for this is X509. In TLS, a client and a server exchange and verify credentials and set up a secure tunnel between them. The version is important. Modern TLS versions are 1.2 and, since 2018, 1.3. TLS 1.3 is both faster and more secure than TLS 1.2. There are many attacks that hackers can mount on a TLS handshake between a client and a server. Down, Crime, Poodle and their zombie and golden doodle variants, Sloth, and Freak, to name a few. The vulnerabilities are many in the cipher suites and allow a hacker to position itself between the client and a server without being detected, resulting in data being exposed or modified. Choose TLS 1.3 and protect your API flows. One important aspect of TLS that makes a difference is the cipher algorithms for key exchange, signature, hashing, and encryption or integrity. There is a multitude of such cipher suites defined for both TLS 1.2 and 1.3. Some of them are considered breakable, denoted in red, and using them increases the risk of attack. IANA hosts a repository of cipher algorithms. Some of them are deemed secure now. Notably, TLS 1.3 only allows cipher suites which are deemed secure as of now. Now moving on to OAuth. The basics are: a client requests an authorization from a resource owner to access a given resource. It obtains a grant, which it exchanges for an access token by interacting with an authorization server. The client then sends the access token to the resource server to finally get that resource in response. In ETSI-MEC, the client is a REST client and obtains an access token from the authorization and authentication entity, or AA entity, and then the client presents that token to the REST server to get that resource. The REST server must check that the token is correct before returning the resource. Access tokens can be of several types with various degrees of security. Finally, a few tips for using OAuth in the MEC APIs. Watch for compromise of credentials, that is, certificates. They need to be provisioned securely. Always set up a secure tunnel first before running OAuth. Some attacks are possible whenever the REST server does not double-check that the client credentials match those that the client provided to the server when the TLS handshake occurred. This is an example of the trade-off that security has: more security at the cost of more checking. In addition, care must be taken when issuing and handling bearer tokens, as they can be stolen. Best to treat them like passwords. Finally, to prevent the client from accessing more resources than permitted, the server should check the access token's scope. So to wrap up and conclude this episode, here's what we've learned. Between two parties, authentication has different goals and outcomes compared to authorization. We've learned the basics of TLS and the importance of choosing the latest version, and the basics of OAuth message flow. Finally, we outlined what to watch for when incorporating TLS and OAuth into the MEC API software. For more information, here are two examples of resources on good TLS and OAuth practices: OWASP TLS cheat sheet and IETF OAuth best practice. So finally, thank you for your attention and interest in security of MEC APIs. I hope you'll continue to enjoy the rest of the MEC Tech series.